fundamental is the first one. So fundamental is the lowest frequency sound present in a musical tone. It is the most predominant frequency as the frequency expands, and I'll explain that in a moment, how sound expands as the harmonic series of notes. But our minds consider the pitch of the complex musical note to be the pitch, the fundamental. It's usually the lowest sound, the most predominant pitch. So that's the word fundamental. Now, from fundamental, the harmonics grow. Harmonics are the other frequencies that are inherent in a musical tone, which are sympathetically activated because they are multiples of the fundamental. Harmonics are the result of the natural expansion of sustained sounds in a resonant environment. It's actually the physics of sound in the third dimension. The harmonics are part of how sound expands. Harmonic relationships are readily recognized by the brain and can be used to assist the body to rebalance itself energetically. So here are the notes of the harmonic series of notes, which is a phenomenon of the physics of sound. Sound expands spherically. Sound is not a point A to point B, directional thing. Sound expands spherically. So you really, and that's one of the reasons Sherry is so brilliant at this. I mean, she has a great spatial, her mind is the spatial stuff really, great, and, math. But if you can imagine sort of spirals of sound coming out of your mouth as you speak, that's more what's happening. So down here on the left, I've got my cursor over here, the lowest note on the left here in the bass clef, that's the note C. And that would be our fundamental. So we're going to look at the first 20 harmonics of the fundamental of the note C. And what we see is, if you read music, you'll understand the notations here. I want to just let you know that if you're seeing this in color along with me, these blue notes, the black notes are the ones that are most in tune and perfect. But when you get into harmonics, you get a lot of little flat and sharp sounds that aren't perfectly in tune with everything else. And that's the nature of the harmonic series and why they created tempered tuning, but that's another subject matter. So up here, too, you'll see +2, -14, +2, -31. These are the deviations from, let's say, the tempered tuning pitch. So if it's -31 here, this note is going to sound not like a B, but more like a B flat. This E sounds a little bit flat, -14. This G flat is -49. So you'll notice that as the notes go up, as the harmonics get higher and higher, they get closer and closer together. So let's look down at the bottom of the page here. If you have any questions about this graph, let me know. Above are the first 20 harmonics inherent within the fundamental of the note C. The harmonic series is the series of notes which expand from and sound with the sustained sound of the fundamental. The harmonics are integer multiples of the fundamental. That is, they're half of the fundamental, or a third, or a fourth, or a fifth, or a sixth, etc. The distance between the harmonics gets smaller and smaller as they expand upwards to much higher than frequencies that the human ear can hear or differentiate between as they get so close together. But also down here, as the C sound expands, some of its harmonics are louder than the others. The octaves, mostly, because they are mathematically the most closely related to the fundamental. They're 1/2, 1/4, 1/8 of the fundamental will be the octaves. Their wavelengths vibrate most sympathetically with that fundamental note that's sustained. And here's a better way to see it. If you look at these, I've circled all of the notes of C, all of the different octaves of C within the first 16 harmonics. of the fundamental C, you see 1, 2, 3, 4, 5 different notes of the C, which is why your ear identifies that sound as C. I mean, that's the most heavily weighted frequency in the harmonic series. The next close to it would be the note G, where in the first 16 harmonics there's one G, there's the second G there, and there's a third G here. So C is the fundamental, and G would be sol to C's do. So I'm going to get out my pitch pipe here and play it's C. C, do, re, mi, fa, sol. That's the G. So do and sol are the most predominant sounds that you hear in any harmonic series, and they really identify the fundamental for you in your brain. Now, some definitions here that would be good to understand. A half step. So in musical notation, the half step is the smallest distance between two notes. An interval is the distance between two different notes, and it's always measured in half steps. An octave, integer multiples of the fundamental. So if C is 16 hertz, its next highest sounding octave is 32 hertz, and the next highest sounding octave after that is 64, and it goes up and up and up. So half step, interval, and octave. And this is a little chart that I put together that we'll use later on in the presentation, but these are the predictable harmonics. Because of the harmonic series of notes, we know the way sound expands. So when we use two different notes at the same time, the interval between those notes will determine what the harmonics that will sound, and the resonance of the environment, that you're in. If you're just outside playing on the beach, you're not going to get a whole lot of harmonics because the wind is going to blow everything away. But if you're in a closed room, and my favorite type of room to play in would be like a 12 by 12 by 12 room, at least, so the harmonics have a chance to really expand. But these, if you go down to explain this chart, it looks a little confusing, but it's created for people who don't read music. This is the interval. If there is an interval of a half step in between two notes, again, the half step from the last page is the shortest distance between two notes. So if there's an interval of a half step between two notes, the musical term for that would be a minor second, an interval of a minor second. The harmonic that's going to be created from that is going to be a half step below the fundamental. So I give you the example over here in this column. If the example of the fundamental of the note is E, and the interval between E and the next note is a half step, that's the note F. So when you play E and F together at the same time, the first fundamental, the loudest that you're going to, or the first harmonic that you're going to hear is going to be D sharp, which is a half step below the fundamental of E. See? Half step below fundamental. So E plus F equals D sharp. Now let's scroll down. We'll do one more example here. Let's say 3.5 steps here. 3.5 steps equals 7 half steps, or 3.5 whole steps, okay? The musical term for that is a perfect fifth. Again, that's that do to sol relationship. Do, re, mi, fa, sol. And when the interval between two pitches or two notes is a perfect fifth, you will always hear the harmonic one octave above and below the fundamental. So again, the example of the fundamental here is the note E in all of these examples, and 3.5 steps above the note E is the note B. So when E and B are sounded simultaneously, you will hear the E an octave below it and probably an octave above it. So that's how you use this chart to figure out, you know, a certain interval or certain notes of the scale that you'll need when you look at your nano voice note bar graph, and then this chart will help you figure out what sounds to make to get those notes.